to relate to what Moshe talked about in the academy in the West Bank area, we also have a very good cooperation with our Palestinian colleagues, in particular in matters of environmental sustainability, since environmental pollution recognize no borders, and the water resource is essential to all people living in the area. So actually we are working day to day with our colleagues from most of the Palestinian universities. But this is being done below radar because in the high official ranks in the Palestinian Academy, there is a lot of contradiction to these efforts, and also funding, but for instance, by the European community is not for joint projects, only for a monolateral project. So if we have a very important project where Palestinian and Israelis in the West Bank are working together, it will not be granted with money to run it. So this is things that we need to change in order to get to keep this area sustainable for human living. And this is actually what I'm going to talk about today, how things were done in the past in matter of runoff management, and why and how we forgot how to do effective runoff management, and what should be done in the future, because we see every day in the news that cities are being flooded and groundwater is being polluted, and this is a really sustainable challenge to all human beings living on this planet. So if I relate to new research, it was new when I first presented it 2 years ago in Geneva. We see that human development is have a negative feedback to runoff infiltration. When we build cities and develop roads and actually also practice agriculture, we cause the ground to be less infiltrative, and more rain is becoming to be runoff and run over the ground and drain into the streams, and eventually flowing into some sort of a lake or sea. And if in the middle it have a city, in many cases it floods the city, as we can see here in northern Israel in Ariel. In the Shiloh Basin near Ariel, we see that despite the climate change trend, which in previous years caused several droughts, we are producing more runoff. So we have less rain and more runoff. This is because we are sealing the ground and not letting the water infiltrate to the groundwater. So actually, what are we doing? We are dwindling the groundwater resource. Since we diluting it less, small pollutants, small streams of pollutant getting into the groundwater are polluting the groundwater more. And in the end, we are also flooding cities that are in the way of the water flowing to the sea. There is a small movie of this flood in Ariel from last year. I will share it. 1 minute. And share the small video. Now you can see it. It's really severe. There was one man lost his life in this flood when he succeeded to save somebody struggled in the car, but after that he swapped away and drowned. So these floodings are severe, and they are becoming more severe from year to year because of development, human development, human urban development. So why does it happen? As I mentioned, it happens because of anthropogenic actions. If we are taking, for example, this area of a new neighborhood in suburbs of Atlanta in the United States, we can see that previously it was a shrub or a forest, and then all of the area is very rough, and the rain before it hits the ground, it hits the trees, so it has less energy and more time to infiltrate. But once we are changing it to parking lots, clearly the water don't have where to infiltrate, and they are accumulating on the asphalt and eventually getting into a drainage. And finally, they are deprived from the groundwater and flooding some low urban area on the way to the ocean. Also, we do not necessarily need to cover everything with concrete. Also, in areas like this where we change the land use from natural shrub or forest, we are causing we're changing the time duration of the drop on the ground. So also, if here we are changing about 100% or 90% from rain to runoff, here we are changing about 50%, and in the shrub about 90% is being infiltrated. So we are causing less than 10% rain to be transformed into runoff. We can see it very nicely even in Switzerland. If you are going to the rural areas of Switzerland, to a field someplace, after the rain, you see that all of the areas that are covered with crops or with grass are dry, and the shrubs are also dry. But the roads, even a temporary road, if a tractor going across the field, there you will have the ponds. There will be accumulation of water because the ground is being once the cover, the organic cover is being reduced, the ground is partly being sealed. So we don't need to do much in order to reduce the effectivity of infiltration to the ground. We just need to alter the natural habitat. A very extreme example of such a phenomena is being day-to-day developed in forests, mainly in the tropical forests of the Amazonas, where owing to industrial trends, forest is being transformed either to agriculture, or in this case of Indonesia and Borneo, to a gold mining area. And we see here that there is a new river that got developed, that only because this forest was deforests. So instead of water running into the ground, we have water running on the ground. Instead of this water being in a very high quality manner infiltrating and enriching the groundwater, they are being polluted and they run to some sort of river and pollute the river. Also in Africa, it's a very big problem of river being polluted owing to industrial runoff. Another thing which which is a hinder of runoff management is just if we are going to a natural drainage basin and change one of its parameters. For instance, if we are making the wetland area smaller, or the shore area smoother. Or the worst thing is to tamper with the river corridors. And here we see an example in Vermont where not a very big flood event tore down the river corridor and they continue the natural meandering of the river. The problem is that this natural meandering is in the yards of the people living near the river. But this is not the reason. This is the cause of some other reason. The other reason is that we need more space to put all of the people that are living in this planet and all the people that are being born in this planet. And if we are looking at the rate of population growth, since the beginning of time, we see that until very recently, it was very moderate. There was a gradual increase in the number of people living on Earth, but sometimes few hundreds years ago there was a certain trigger which caused this. We see that the rate of population growth is tipping high. See, and what is this point of time? The Industrial Revolution. Since the Industrial Revolution, it is much more easy to comfortably live and get into old age because you don't need to work so hard, and because the health system is better. And so we are coping with annual growth rate instead of 0.2 before the Industrial Revolution to up to 2% per year since after World War II and until the 90s. Since the 90s, it got a little bit moderated to 1%, but still it is certainly growth rate which is non-sustainable. Additional impacts of the Industrial Revolution over groundwater management and runoff management are motors and pumps. Once we can pump water from one place to the other, we don't need to be so preservative in relation to this resource that is called water. Here we have a very nice example of a very ancient pumping station. All of the systems are 19th century, and for decades it used to pump water from the Solomon pools to the Hebron area. Of course, that for decades now it is already not operative, but it is being preserved in a good manner, so people can go and see these ancient pumps sitting there. It is very impressive. If somebody is in Hebron or Bethlehem area, it's worthwhile going to see the Solomon pools. So what was done, how people managed runoff and water before the Industrial Revolution? So let's go to the very beginning, the Chalcolithic period. It's actually the start of people managing nature, and we will look at two sites in the Ayalon Basin. Moza, the site in a place called Moza near Jerusalem. It's the upper part of this basin, and the other site actually in middle of Tel Aviv is very near the end of the Ayalon River before it is being released to the Mediterranean Sea. So what we see in the upper part of this basin, we see that people used to live on a river terrace, and this is a cross section within this river terrace. And when we've been there, we looked closely and we saw something very interesting. This river terrace is partly artificial. We have the natural river terrace until a certain height above the stream, And we saw that above it, in several stages, it was raised. These people that lived on the river terrace poured the pebbles and other type of aggregates, so it will be higher and higher, and then they built their sheds or houses or tents. So I don't know exactly in which type of housing they lived, but they understood that if it will be higher, the chances of the river during flooding swapping their houses and themselves is less probable. The most interesting thing they did is that they used infiltrative strata. So the water it wasn't just higher, it also conduited the water through it. It is very sophisticated for people living for almost 5,000 years ago. In Tel Aviv, we see even something which is even more sophisticated. When they scrapped this Kurkar ridge, actually it's a fossilized sand dune, in order to build another house like this one, they found more than 100 shallow pits. If we look at this cross section of this pit, we see that it is like an upside down mushroom. Everybody that was near the seashore or a lakeshore and dug with his kids or as a kid to the level of the interface between the water and the water that is coming from the sea or from the lake, know that the pit is starting to collapse and the water are flowing into the pit. So, and then we're getting something which looks like what we see here in this photo. We assume that they dug all of these hundred and something of pits in order to clear the water that are coming from the river, because drinking the water directly from the river is dangerous. The water were probably polluted because this is the end of the drainage basin. So all along the way, they accumulated some sort of pollutant. And if people used to drink directly from the river, probably they got sick. So what these people did is dig in shallow pits to the level where water from the river ran to the pit through this sandstone, which was used as a natural filter. This is our assumption for the cause for people to dig so many pits. So these are two very sophisticated way of thinking about optimizing runoff and water potable water use. Let's go to the Iron Age, a few thousand years later, and look at Khalat Asiha Ridge. It is actually in Rosh Ain. It's a city in central Israel, and they have a huge cistern. And it was actually an enigma why they needed such a big cistern. And the bigger enigma was, how can it be full all of the time? Because this is map and hydrological analysis of this area. The cistern is here. It should have accumulated only this yellowish green area, even part of it. So it shouldn't be so big. We see that on the ground they have several shafts conduiting water to this cistern. What is more interesting, that they utilized a fault line to increase the area of the immediate drainage basin to the cistern. And what they did more is use a sinkhole, natural sinkhole, also to increase the area of the drainage basin to the cistern. And in addition, they dug a small tunnel to catch all of this bluish area. So in fact, they use about 3 or 4 times bigger area to sustain themselves during all year round, both for agriculture and for drinking purposes. And a master student of mine is checking the quality of water, and we see that this is the end of the summer, and the water filled the cistern in during the winter, and still the water are safe for drinking. They don't have any type of bacterial pollution, and the water are sweet without a lot of salt. So this is very impressive. If we are proceeding to the Roman era, we see combination of both things. We see cisterns. This is Dir Saman area. It's a monastery that also it accumulate. They used to live there only a few tens of people, and the amount of food they stored and produced there, and the amount of water that they stored there was for several hundreds of people. So we suspect it was an outpost of the Roman Empire when they needed to, the late Roman time, when they needed to send the soldiers to the area, and the soldiers used to camp around this monastery, and they had enough water and they had enough food to sustain all of the soldiers. So it have a very sophisticated both above ground and below ground system of water preservation, water pools and underwater pools. And if we go to Cyprus, we see that there is a constructed house there, also a big farm, and all of this farm is piped. All of the water from the roofs, from paved areas, are being conduited again to cisterns, so they will be able to use the water that are being accumulated during the winter, also in the summer. And in the same site, we saw the Chalcolithic settlement. There is also a Roman settlement, and we see that the Roman learned from their previous inhabitants of the area, and some of the streets actually are infiltrative. Here you see this blue and iron system is to check infiltration. Rate of infiltration. We see that the houses themselves were impermeable, but the streets were permeable. And below the street, they had a chain of drainage, which returned the surplus water to the stream. So they had actually permeable sidewalks during the Roman era. This is something, for instance, that we hardly have today. If we are going
Merci
further
beaucoup, Dr. Yaakov. I'm sorry to interrupt you, Yaakov, but Nina Modera is supposed to leave now and to leave us, unfortunately. So thank you very much for your presentation. Merci beaucoup, Dr. Yaakov Anker, pour votre présentation. Notre traductrice, Nina Moldauer, doit malheureusement nous quitter. Je ne sais pas si vous voulez conclure, peut-être. Would you like to just say last few words to end your presentation?
Yes, I have only two slides, so it's the end of the presentation. Okay. Thus, I wanted to show how agriculture can actually improve groundwater runoff management. You see here, this is the same area. This is a new garden, and this is an old agriculture area. See that here it is not flooded at all, and the new garden is flooded. So let's go. And then we can do all of these things that used to be common previously. We can do it also today in urban planning. We can see rain gardens and permeable parking lots and green roofs. And also in Switzerland, it is common. In Geneva, we saw places like this. And also a friend of mine sent me an example from Moscow. And actually in Africa, they didn't forget all of the system. So we have a place to go and learn how things should be done. And to summarize, the common trend today is that we are producing more runoff, but it's not a necessity. With a very small change in state of mind of human development, we can go back to the times where we used to utilize runoff and water in an optimal way, and by that to preserve this very significant resource of water and prevent misfits that are been occurring because we forgot to control it as we should have. Okay, so thank you very much.
Merci beaucoup, Dr. Anker. Thank you very much, Yaakov. So now we're gonna on va passer aux questions-réponses. Donc je crois qu'il y avait peut-être une question. Donc tout d'abord pour encore donc professeur Yaakov. Do you think that the deforestation could be also directly guilty of the climate change? Est-ce que vous pensez que la déforestation est aussi directement en lien avec les changements climatiques? Est-ce qu'il y a un lien de cause à effet? If we would transform the Earth into Mars, we would have a tremendous heat augmentation. Si on transformait la Terre en Mars, est-ce qu'on aurait donc une augmentation énorme de la température?
Yes, for sure. I think that it doesn't get it should have been stressed much more that when we are changing forested area into an unforested area, we are intensifying global climate change in two ways, at least in two ways. First of all, we are assimilating less GHGs, greenhouse gases. And second of all, we are emitting more greenhouse gases from this area. And in particular, when we are using in purpose or accidentally fires as a way to deforest an area. When we are, and now we see that we have a tremendous amount of natural and accidental forest all over the world. I'm certain that the excessive amount of CO2 being released to the atmosphere is something that we will experience very severely in the climate change of the coming years.